Okay, so let's do practice quiz 8 and number 2. So before doing it, let me just give a brief talk about the normal distribution. So it's a type of bell curve. So the normal distribution is the most important probability distribution in stats because it fits many natural phenomena. For example, it fits heights, blood pressure, IQ scores, and many other things. It's also known as a Gaussian distribution or a bell curve. So here's a picture of a normal distribution. This is a special one. It's called N01. This is called the standard normal distribution. Let me go down here. So N01 is called the standard normal distribution, where 0 is the mean and 1 is the standard deviation. Okay, let's keep going. So there's a way to transform from the standard normal to any other normal distribution. So here, this would be a normal distribution with mean mu and standard deviation sigma. We can map that into the standard normal with this mapping here. So let me just show you the picture. So here's our normal distribution. So we can map it into the standard normal using this mapping, x minus mu over sigma. And then when we do that, we can then use a standard normal table to find area. So you'll see, let's do an example now. Here's a question on practice quiz 8. A professor's exam scores are distributed normally with mean 80 and standard deviation 5. Use the standard normal table given during lecture. I guess you have a link to it here to answer the following questions. So let's look at part A here. So looking for probability. Let's actually say insert equation. So probability x is so looking for find a probability that student scores 82 or less, so less than or equal to 82. So we're looking for that. So we're going to have to transform it to a standard normal. So we're going to use our z-score. So it's basically be then z less than or equal to, so then we'll do fraction here. So on top, so z-score is basically going to be our 82 or x value minus the mean, which is 80. So it'd be 82 minus 80 divided by the standard deviation. Standard deviation here is 5. So dividing by 5 here, that will transform into a standard normal. So working this out, I'll check. This will be then. Oops. Undo. So equal then probability z is less than or equal to, we worked it out as 0.4, say 0.40. Okay, so now we're going to go to the standard normal table. So there's a link to that in the online materials. So let's do that. I'm going to pull it up now. Let's see. Okay, so I've pulled up my standard normal table. So this gives me areas or probabilities. So going back to our question here, we're looking for 0.4 as our z value. So you're going to look at 0.40. So you go down here, and we're at 0.4, go across, and then the next number is 0, so it's 0.40, it's still come down here, and there's no number down here. So that's the number we're going to put in over here. So it's 0.65, what was it? 6554. So it's basically saying that there's a 65% chance, 65.54% chance that a student scores an 82 or less. Okay, so let's keep going. Okay, so part B. So what's the probability that a student scores a 90% or more? So we're looking for here. So let me insert equation. So probability, now x is this time larger than or equal to 90. So we have to do our z-score in this, so it'll be a probability then. So changing it to z, so it's basically changing it to the standard normal, be then subtraction. So we'll do our z-score here, so it'll be, this time it'll be 90 minus 80. Again, 90 is our x, and then 80 is our mean. Then divided by our standard deviation, which is 5 over here. Okay. And that will equal then probability z greater than or equal to, so that's just 2. Okay, and then this will equal then, I'll explain in a second. Let me just work it out right now. So we probability 1 minus probability z is less than or equal to 2. I claim, I'll explain how I got this in a second. So let's look at our table. So we're looking for 2 on the table. So 2.0, let's scroll down here. There's 2 right there. Let's draw here. So 2 is there. And it's 2.0. So it's gonna, so if you go up here, oops, I'm gonna just, so actually, let me do this. So number is 2.0, so you have the 2 here, 0.0, so I guess it's going to be 0, 0, so it's going to be just coming off this guy, and then coming down up here. Look at this guy here. So it'll be 0.9772. Okay, so it's close this. Come back over here. It'll be then 1 minus 0.9772, which equals 0.0288. So let me explain why I had to go 1 minus. Yeah, over here, the table gives you area to the left of z, so that means less than or equal to z. It does not give you area to the right of z, greater than or equal to z. So we're going to have, that's why we have to adjust. That's why over here I went 1 minus. So let me explain in a picture. Okay, so here's the picture. We have our first normal distribution. So we're looking for z greater than or equal to 2, so it'll be the area to the right of 2, so here's 2. I claim that's the area underneath all the standard normal distribution minus the area to the left of 2. Now the table gives us this value. The table gives us areas to the left. So it doesn't give us areas to the right. But also this guy here, it will be equal to 1 because it's the area underneath the probability distribution is always 1. It's like a probability histogram is always 1. So the total area is 1 always. So you can write this then as probability z greater than or equal to 2 will equal 1 minus, this will be probability z less than or equal to 2. So that's how I got that equation. So let's keep going. Okay, so I just noticed actually there should be 2.0228 here. Okay, so we're done with part B. Okay, so there's about a just over 2% chance that a student would score 90% or more. You have to move the decimal point 2 places to change this to a decimal. So it'd be 2.28% chance. Okay, so let's go on to part B now. Sorry, part C. So this one, we define the probability that a student scores a 74 or less. Okay, so probability x is less than or equal to 74. So we'll do our z-score on this. So it'll be z then less than or equal to so it'd be 74 minus our mean. We go up there, our mean was 80. Go up there. Let's see here. See, our mean's 80. And our standard deviation's 5. Oops. Divided by 5. Okay, so working this out, let you check if you do that fraction and reduce it, change it to a decimal. It's negative 1.2. Okay, so let's go to our table to find this guy. So going to our table. So here's my table. Now my value was negative 1.2. So looking at our table, we're looking at the negative column this time. So go down there, like for negative 1.2. I guess it's negative 1.2. There's no a number after it, so it's 0. So let's go down the 0 column. So we get to here. So it's that guy right there. So it's 0.1151. Okay. Here. So equal 0.1151. Okay, so we're out of time in this video. I'll do the last part in the next video.